Welcome to Brain Vision.
Hi everyone, this is the solution to problem 12, chapter 24 of God Knows Physics. And this question is asking us to find how many times we can fit an electromagnetic wave into the pulse of a laser light. So the light pulses last a time of 2.7 times 10 to the minus 11 seconds, and the frequency of the light emitted is 5.2 times 10 to the 14 hertz. So there are two ways we can do this. The first way, which is good for part A, is that the number is equal to the number of periods that you can fit into the pulse of the laser. And so that's what I'm writing here. This is the time of the pulse divided by the period of the electromagnetic wave emitted. And so we know that the period is equal to 1 over its frequency. And so 1 over f gives us f on top. And so that's how we get f times Tp. Now the second way, which is more revealing and is going to help us answer part B as well, is to say that the number of waves that we can fit in is equal to the distance that the wave travels. And so this is Ctp during a time of the pulse divided by its wavelength. So in other words, if the wave travels a length of this size, and we have a wavelength, or we have a wave that looks like this, then the question is, how many segments such as this can we fit into this length? And so using the fact that c, the speed of light, is equal to its wavelength times its frequency, we can write lambda in terms of c and f. And so this is equal to c times Tp divided by c over f. You can see that the c, the speed of light, cancels, and we end up with the same thing as we had in option 1, which is Tp times f. And so the answer to this first part is going to be that it is 14 times 10 to the 3. So we can fit 14,000 waves or wavelengths into one pulse. And so following this way, option 2, if we look at the question, or the second part of question B, then we realize that the speed of the wave, or the speed of the speed of light in the medium, does not matter because the speed cancels. And so if we wrote this as being the number being equal to the speed in the medium, water, times the period of the pulse, which is the same as before, divided by the wavelength in the medium, then this formula still holds. And so putting everything in exactly the same way as we did before, just above, we find that this is going to be Cw over frequency. And since the frequency doesn't change, that means that Cv drops out, and we have, again, f times Tp, and the answer is, again, 14 times 10 to the 3, or 14,000 times can we fit the wave length into the length of the pulse.